Hello, my lovely students. How are you? I hope you are quite well and your study is going very fine. This is lecture number 16 of aldehyde and ketone, and we are going to understand here the oxidation of carbonyl compounds. Students, see that we have done in the method of preparation of aldehyde in the first and second lecture that what some reagent I am going to write here that the CrO3 and water and that is a form that H2Cr what H2Cr O4. This is the what chromic acid, correct? This is the chromic acid. Now students, next is that what we have done that KMnO4H plus or K2Cr2O7H plus, correct? So or conc HNO3. These reagents we have done that. So these reagents are very strong oxidizing agents. Student, these reagents oxidized 1 degree alcohol into acid and 2 degree alcohols into ketone, correct? That's fine. Now here we have to study that how these reagents, especially KMnO4H plus, K2Cr27H plus and conc-HNO3, how these reagents will react with aldehyde and ketones and why their reactivity is faster in aldehyde and then the ketones. Okay, so first we oxidized CH3 CHO. Here we take that oxidation and then compound is formed that CH3 COOH, correct? So what we have observed here, how many carbon here? 2 carbon, that the same number of carbon you can get here after the oxidation. So the when aldehyde oxidized, what happened? Aldehydes oxidized 2 carboxylic acid, 2 carboxylic acids having same number of carbon atoms, correct? That's fine, it's happened. But same thing happen with the ketones? Not at all. Ketone oxidized with the lesser number of carbon atoms. Students, what happened? Ketones oxidized with lesser number of carbon atoms. See, why it will happen? See that CH3 C double bond OH, aldehyde is that, and here is that ketone. Students, so what happened in aldehyde? There is a carbon hydrogen bond, and here is a carbon carbon bond. Which bond is easier to break? Students, carbon hydrogen bond is very weak as compared to carbon carbon bond. So it's very difficult to break this carbon hydrogen bond. Therefore, either the KMnO4H plus or K2Cr27H plus or conc HNO3 can easily break these CH bonds and can be converted into the acids. But here is carbon-carbon bond, if the high temperature, that elevated temperature, high temperature is used along with the oxidizing agent, that will form the fracture of compounds. Right, so fracture of compound you will get that because ketone is not easily oxidized because of carbon-carbon bonds. So of course we have to use the high temperature, elevated temperature along with the, some oxidizing agent like conc HNO3 or KMnO4H plus or K2Cr27H plus. So I hope you understood that why aldehyde is oxidized easier than the ketones, because of here the carbon hydrogen bonds, right, which is easily to be broken that by the KMnO4 or KMnO4 or conc HNO3. Now here is that what I am telling you. Suppose ketone, if we take the ketone, symmetrical ketones. Western symmetrical ketone is that C double bond OCH3. Why it is called symmetrical ketone? Because both sides same number of alkyl. So if we have a symmetrical ketones taken here and the 4 moles of oxidation means who will provide the 4 moles oxygens? That will conc HNO3. The conc HNO3 or KMnO4 that will provide whatever number of oxygen will required for oxidations. So that the things is going to be happen here. What that things is that will convert the CH3 here to here, that oxidation C1, 2, 3. So bond cleavage between the C1 and C2, and the things will happen that CH3COH plus formic acid, right? And the further the you can see here the formic acid can be oxidized again. So when we take that oxidation, that will convert into CO2 again, CO2 plus H2O, right? So why the students, acetic acid will not be oxidized because that carbon is there. That further oxidation is not possible because this carbon. Okay, now suppose we have unsymmetrical ketones. What? Unsymmetrical. Suppose you have an unsymmetrical ketone, then in that case, what is going to be happen? Students, suppose you have unsymmetrical ketone like that, CH3, C double bond O, CH2, CH2, CH3, right? 1, 2, 3, 4, 5, right? So this is the hexane 2 on. So the hexane 2 on, how it will be oxidized? Student, the two cases is there. Suppose that conc HNO3 is taken, then the case is here what? So the one case is that first C1 and this whole the bond between C1 and C2 is break here. C1 and C2 is cleaved here, and then the form that like that. Then the C2 and C3 bond cleaved here. So what is going to be happen then? C1 C2, the first is form that formic acid, uh, along with that the CH3 CH2 CH2 and COOH, right? And second, the cleavage of C2 C3, then what you will get that CH3 COOH, and second is that here the CH3 CH2 and COH. Students, can you tell me which is the major product? Student, according to Popop's rule, this is the major product. Why? Because you can observe here, this is the second carbon which contains the carbonyl group. So carbonyl groups remains with the smaller carbons. Here is that carbonyl group is here, one carbon, that is acid, and second carbon with the 1, 2, 3, 4. Means carbonyl group here with the 4 carbon atoms. Okay. Now you can check here the carbonyl group with the 2 carbon atoms. So this part is the major part as compared to here. It is a minor part, correct? Now what Popop's rule is that? Students, what the Popop's rule is that? See that. What the Popop's rule says that? Popop's rule said that what carbonyl group remains with what? With the remains with the smaller alkyl group. So I hope you understood. Uh, this is the oxidation. So what we have understood here, students, two things. Why aldehydes oxidation of aldehyde is easier than the ketone? First, second, when the ketone is oxidized, the fracture of compound will form. After fracture of compound, which part is measured? Who will decide? It is decided by the Popop's rule, and we have done that. Okay. Now in your NCERT there is given C1, C2, C3, R1, and R2, and the 4 product is formed. Now you tell me which is the major product and comment me. Send me that. So this is the major product. Okay, let's understand the next oxidations, which is the selenium dioxide. Selenium dioxide. See, the second oxidation of carbonyl compound is selenium dioxide. Student, selenium dioxide also oxidized. This is selenium dioxide. Here, selenium dioxide also oxidizes the aldehyde and ketones. But what aldehyde, students? The aldehyde which contains the methyl group. See here. First is that the first preference, the aldehyde must contains the methyl group. Second, aldehyde must contains that first preference is the methyl group, and second preference is the methylene group, CH2. Second preference is that methylene group. So my question is that is formaldehyde will oxidize? Formaldehyde will oxidize through selenium dioxide? Not at all, because formaldehyde does not contains neither methyl group nor a methylene group. So or benzaldehyde will not be oxidized. Keep in mind, because that also not contains that methyl group or methylene group. So let's understand through the one example, students here. CH3 C double bond OH, and you have taken that selenium dioxide. Here is the methyl group that will oxide into that because that is the one carbon and which converted into formaldehyde. Okay, so there is the formaldehyde will form. This is the glyoxal. Next is that suppose we have taken that CH3 and C double bond OCH3, and we have taken the selenium oxide. So here is the 2 methyl group. So any one methyl group can be oxidized into the aldehydes. So what is going to form? Suppose one more selenium oxide you have, then it will also oxidized. Or suppose you have tolerance reagent, then that will oxidized, or failing solution that will oxidized. Okay. Now next is that one more compound. If we take here, what that there is a CH through C double bond. In this compound, I have taken the methyl and methylene group both. Okay, so here is the selenium oxide we have taken, selenium dioxide. The two things will happen strings. One is that here is that methyl group and second is the methylene group. So and you have only one mole selenium dioxide, then what happen, that will convert it into H, C double bond O, C double bond O, CH2, CH3 will form first of all. Second is that uh, okay, methylene group also you have, so methylene group can be oxidized like that, C double bond O, C double bond O, CH3. Okay, so my question is, what is a major product? Students, see that first, I earlier said that the first is that first is a major product of methyl, and then second preference is the methylene group. So first preference is the methyl, means it is a major product. What happened is a major product. Here is the major product, and there is the minor product. So it is a major product and minor product. So what these things? What is the name of this compound, students? It is name is that ethyl glyoxal. What? Ethyl ethyl glyoxal. Okay. So ethyl glyoxal, it is a major product, and butane butane 2,3 dione in the minor product. One more example we take here. Suppose you have a benzaldehyde strength. Benzaldehyde, what will happen? Benzaldehyde, if you have that the selenium dioxide we have taken, this compound can be oxidized into the, here is that like that C double bond O, C double bond OH will, right? Okay, students, one more example. Suppose cyclic ketone you have. The cyclic ketone is selenium dioxide. Then what happened? Here is the methylene group. Here is the methylene group. That will convert it into double bond O, double bond O will form. Okay. So we have done the students two oxidations. One is with the selenium dioxide, and second is that Mn4 or K2Cr7 or Concatron 3. So I hope both the process, both the oxidation you understood. Students, once you understood that, please like, share, and subscribe the channel. Thank you so much. Have a nice day.